Welcome back to the garage. This is Token Teardown, where we put crypto projects on the lift, look past the headlines, and figure out what actually works when you stop talking about it and start using it. Because in here, saying AI doesn't earn you a free pass. We use AI every day. We run real workflows. We test models constantly. Some models are great for video and animation. Some are great for workflows. Some are great for everyday questions. Some are great for scraping and structuring data, and some are just overkill, slow on simple stuff, but solid when the work actually gets complex. So no, picking a model isn't impressive. And dressing up a workflow, attaching an LLM, and calling it an agent doesn't move us. In this garage, an agent only matters if it does real work, runs without babysitting, and still works after the hype leaves the room. That's the standard, which is why today's project is interesting, because this isn't just Fetch.ai anymore. It's Fetch.ai as part of the Artificial Superintelligence Alliance, a combined effort bringing together agents, data, and AI services under one roof. That's a serious ambition, but serious ambition doesn't get a free pass. This isn't a flashy supercar situation. This is a Porsche 911 GT3 RS situation. Not impressive because it flexes, impressive because every system has to work together under stress. Miss one link, software, coordination, execution, and the whole thing loses composure. That's the category this project is trying to play in. So yes, we will talk price. We get it. That's everyone's favorite section. But before charts, targets, or when moon, there's a more important question. Does this actually deserve a parking spot in your garage? We didn't come in here to hype anything. We read the white papers. We checked the architecture. We dug through the GitHub commits. We ran every test we could, short of actually paying to build a full production app on the network ourselves. And if the Artificial Superintelligence Alliance wants builders building here, real usage, real feedback, real stress testing, we're in. No cost, no hype, just work. All right, lists up. Let's get into it. Now, every great race team needs a pit crew, because no matter how good the car looks on paper, it doesn't win races without the people who designed it, built it, and know how to fix it when something breaks at speed. So before we get into agents, architecture, or upside, we need to talk about who's actually behind Fetch.ai. And first, quick pause, because you're going to hear a term come up with this group, AGI. AGI stands for Artificial General Intelligence. Plain English, it means AI that can reason across different problems, not just do one narrow task. Not a chatbot, not a script, not press this button when that happens. Think less tool and more problem solver. Whether AGI ever fully shows up is still debated, but the key thing here is this. The people working on Fetch and the Artificial Superintelligence Alliance have been thinking about that problem for decades, not since last bull run. That's why these names matter. At the center of Fetch.ai is Humayun Sheikh. He's the founder and CEO. And before Fetch, he was an early investor in DeepMind, the AI company Google bought because their tech was that far ahead. That tells you something important. This isn't someone chasing crypto narratives. This is someone who's been around real AI long before it was cool to tweet about it. On the technical side, you've got Toby Simpson, the co-founder and CTO. This is the guy making sure the engine actually runs. System architecture, agent frameworks, the unglamorous stuff that either works or doesn't. He also comes from a DeepMind background, which explains why Fetch focuses more on coordination and systems than flashy demos. Then there's Thomas Hain, the chief scientist. This is the research side of the shop. Machine learning, distributed intelligence, making sure the math and theory line up with what's being built. Now, widen the lens, because Fetch isn't operating alone anymore. It's part of the Artificial Superintelligence Alliance. That alliance brings in some heavy hitters. One of them is Ben Goertzel. If you've been around AI long enough, you've heard this name. He's been working on AGI concepts for years. Academic, theoretical, long horizon thinking. You don't have to agree with every idea he has to recognize the clout. This is not a tourist. Then there's Trent McConaughey. His lane is data, who owns it, who sells it, and how it actually gets used without everything turning into a centralized mess. That matters if you're talking about agents making decisions based on real information, not just guessing. So zooming out, this isn't a meme team. This isn't anonymous founders. And this isn't people learning AI off YouTube. These are real builders with real backgrounds in AI, systems, and data. That doesn't mean they automatically win, but it does mean the pit crew knows what they're attempting. Now the real question becomes, did they actually build a machine that lives up to that level of ambition? Let's get under the hood and find out. All right, this is where the teardown actually begins. Up to now, we talked about the team and the ambition. Now we talk about the machine. What is Fetch actually doing in the real world? Fetch is not trying to replace chatbots. It is not trying to replace apps. It is not trying to impress end users. Fetch is trying to remove humans from the middle of repetitive coordination decisions. Situations where software already knows the inputs, the rules are already defined, but a person still has to approve, click, confirm, or reconcile. Fetch is built for environments where decisions happen constantly, where data changes in real time, and where humans slow the whole system down. Instead of people clicking buttons, you deploy agents. And in this context, an agent is not a personality. It is not something you talk to. It is a digital worker with a job. That job might be monitoring prices, tracking supply and demand, scheduling resources, comparing options, or triggering actions when conditions are met. The agent watches inputs, follows rules, keeps state, and acts when it's supposed to. Fetch provides the coordination layer that lets these agents identify themselves, find other agents, communicate safely, and act without one central company controlling everything. That is the core function. Now here's the honest part. There are already Web 2 systems that automate parts of this. Most companies already use software to schedule, to monitor, to trigger actions, to route decisions. And in many cases, that works fine. So Fetch is not trying to replace Web 2, automation inside a single company. That is not the lane. The lane Fetch is aiming for is where Web 2 starts to break. Situations with multiple parties, shared data, automated decisions, and no untrusted owner. The moment you have competitors coordinating, or companies across jurisdictions, or systems that no one wants controlled by a single platform, Web 2 slows down. Humans get inserted. Lawyers get involved. Approvals stack up. Decisions stall. That is the crack Fetch is trying to fill by replacing trust with rules, by replacing middlemen with automation, by letting machines coordinate where people cannot or should not. Now this is where the Artificial Superintelligence Alliance changes the scope. Fetch alone handles coordination, but coordination by itself has limits. Agents without intelligence are just scripts. Agents without data are blind. The Alliance is trying to connect coordination, intelligence, and data into one system. The goal is for agents to pull real data, use real models, make decisions, and execute them economically without handing control to a single company. That is not a small upgrade. That is a systems-level bet. And systems-level bets do not fail quietly. If this only recreates what Web 2 already does, but with more friction, it fails. If it does not become something people depend on, it fails. This only works if it becomes necessary, not optional. So this chapter ends with the pressure clearly defined. Not, can this work? But will anyone choose it? Because coordination tools either become invisible infrastructure or they get ignored. There is no middle ground. Now that we understand the build, the only thing left is to test it. Where does this actually win? Where does it lose? And does that win justify the complexity? Let's keep going. All right, now let's get into the tech itself, because this is not just an agent platform, and it is not just a blockchain with AI branding. Fetch is building a full coordination stack, and agents are only one layer of it. At the base, you have the network layer. This is where identity, permissions, and shared rules live. It is not there to be fast or flashy. It is there to make sure actions can happen in a shared environment without one party cheating or taking control. On top of that, you have the agent layer. And here is something important that gets lost in a lot of conversations. These agents are not exotic or mystical. At their core, they can be built using simple Python scripts. You are not writing some alien language. You are defining behavior, inputs, rules, and allowed actions. Agents here are not personalities and they are not assistants. They are digital workers with defined jobs. And there are different kinds of agent builds. The simplest type is a watcher. Watcher agents run continuously. They monitor data streams, prices, states, or conditions. They keep memory of what changed and when. They do not decide and they do not act. Their job is persistence. Then you have decision agents. Decision agents take inputs from watcher agents or external systems. They apply rules, thresholds, and constraints. Sometimes they reference models to interpret messy inputs, but they do not guess. They evaluate allowed options and choose from them. This is where logic lives. Most of the time, the intelligence here is rules, not models. Then you have execution agents. Execution agents are where decisions turn into actions. Transactions get triggered, resources get allocated, schedules change, shared state updates. This is the most fragile layer. If identity permissions or coordination rules are sloppy, everything breaks here. Fetch is designed so these execution steps can happen without trusting a single operator. Now, step back. Those three types together form the real architecture. Watch, decide, act. That is the system, not chat, not prompts, not conversations. What makes this different from normal automation is that each agent has its own identity permissions and state. They are not just functions inside one company system. They are designed to coordinate across boundaries, across organizations, across systems that do not trust each other. That is the core distinction from Web 2. Now, when you zoom out to the Artificial Superintelligence Alliance, the scope widens. Fetch handles coordination, but coordination alone has limits. Agents without intelligence are just squips. Agents without data are blind. The Alliance is trying to connect coordination, intelligence, and data into one stack. This is where models come in, not as decision makers, but as interpreters. Models help agents understand unstructured inputs like text, images, or complex signals. But models do not get the keys. They suggest, they rank, they assist. Rules still decide. That separation is intentional and important. So when you hear agents in this context, you should think distributed workflows with identity and coordination. And when you hear superintelligence, you should think long-term, system-level coordination, not magic. This is why this build is hard. It is not one feature. It is not one app. It is multiple layers that all have to work together. If any layer is weak, the whole system degrades. That is why this is a systems bet. And that brings us to the real test. Is this stack usable by real builders, or does it collapse under its own complexity? Because that is the line between ambition and adoption. Let's keep going. Now, this is where we have to connect the tech to the token, because none of this matters if the token is just decoration. So what does the FET token actually do? At a basic level, the FET token exists to make coordination possible without trust. It is how the system prices behavior. It is how it prevents spam. And it's how it enforces rules without a central operator. When agents run on Fetch, they need identity, they need permission, and they need a way to pay for actions. That's where the token comes in. FET is used to register agents, stake behavior, and access network resources. If you want an agent to operate continuously, if you want it to be discoverable, if you want it to interact with other agents, there has to be cost and accountability. Otherwise, the network gets flooded with junk. The token is also how execution happens. When an agent takes an action, triggers a task, allocates a resource, or settles an outcome, FET is what moves. That is the economic glue. Now here is where usability and tokenomics collide. If the token friction is too high, if gas costs are unpredictable, if staking requirements are confusing, builders will not stick around. This is why the developer experience matters so much. because every extra step between writing a simple Python agent and deploying it with real value attached is a drop-off point. Fetch does not win by making the token speculative. It wins if the token becomes invisible infrastructure, something builders use because they have to, not because they want to trade it. Now zoom out to the Artificial Superintelligence Alliance. This is where the role of the token expands. As agents start using models, pulling data, and coordinating across systems, the token becomes the settlement layer between intelligence coordination and data. Instead of paying a platform, instead of trusting a middleman, agents pay each other directly. That is the theory. But here's the pressure. If real agents are not running, if real work is not being done, if economic activity does not flow through the network, then the token has no gravity. At that point, it becomes a narrative asset, not a utility asset. So the test for FET is simple. Does usage grow because builders find it useful, or does interest only grow when price moves? Because long-term value only comes from the first one. Everything else fades. So now, the teardown tightens again. Is the token doing real work, or is it waiting for speculation to carry it? That answer matters more than any chart. Let's keep going. Now let's talk about the business side of this and whether it's actually making money. Because this is not just a protocol. This is a company. Fetch is a real operating business with employees, leadership, and a long-term strategy. This is not a DAO-first experiment, and it is not a hype-driven crypto startup. The company builds the software, maintains the infrastructure, and works directly with enterprises, developers, and partners. From a business standpoint, Fetch operates like a deep tech company, not a consumer app. They spend time on research, on pilots, on long horizon problems, and on infrastructure that is meant to survive multiple cycles. That also explains why growth looks slower than narrative-driven projects. They are not paying for usage, they are not farming activity, and they are not trying to manufacture demand. They are trying to sell something that is genuinely hard. Coordination without trust. So is this producing revenue? The answer is yes, but not at scale. Most of the revenue today comes from enterprise engagements, paid pilots, research collaborations, and development contracts. This is normal for a company at this stage. Revenue exists, but it's limited, and it's not yet scaling. This is still a build and validation phase, not a harvest phase. You do not see large on-chain fees. You do not see massive recurring protocol revenue, because the company is still proving the technology works in real environments before pushing for scale. That distinction matters. The company can generate revenue and continue building even if the token is quiet. But for the token to matter long-term, usage and value have to eventually flow through the network itself. That means agents doing real work, settling outcomes, and using the token as part of normal operation. Right now, that loop is still forming. So the honest takeaway is this. Fetch is a real company with real revenue, but it is early, it is limited, and it is not yet reflected in on-chain economics. This is not a cash machine. It is a long-cycle infrastructure business, which brings us back to the final question. Given the company, the tech, the token, and the current stage of adoption, does this earn a parking spot in the garage? Let's close it out. Now, we need to connect the token and the data because this is where the system either makes sense or falls apart. Agents do not create data, and Fetch does not run giant data centers. There is no secret dataset, no hidden feed, no magic source of information. Agents get data from the same places data already lives today: enterprise databases, market feeds, APIs, sensors, existing infrastructure. Fetch does not replace those systems. It connects to them. The difference is not where the data comes from. The difference is how that data is accessed, coordinated, and paid for. Web 2, one company usually owns the data, controls access, and sets the rules. In this system, data can stay where it is, owned by whoever owns it, but still be used by agents under clear conditions. That is where the token comes in. The FET token is not there to speculate. It is there to price access, enforce rules, and prevent abuse. When an engine wants to run, it has to register, it has to stake, and it has to pay to operate. That cost is what keeps the network from being flooded with junk. When an agent uses data, triggers an action, or settles an outcome, value moves through the token. That is the economic layer tying coordination and data together. Now, here's the pressure point. If agents are not doing real work, if data access does not flow through the network, and if outcomes are settled elsewhere, the token has no gravity. At that point, it becomes narrative, not infrastructure. But if agents are actually coordinating, pulling data from many owners, making decisions, and executing outcomes, then the token becomes invisible plumbing, used because it has to be, not because people want to trade it. That is the only version where this works long term. Now zoom out. Why does any of this matter? Because coordination and data are not small markets. They sit underneath logistics, energy, supply chains, finance, healthcare, manufacturing, and infrastructure. These are not billion-dollar niches. This is where the 20 trillion total market number comes from. Not from retail users, not from apps, not from speculation, but from automating coordination across industries that already move trillions of dollars every year. If even a small percentage of that activity shifts from human-mediated, platform-controlled, and trust-based to automated, rules-based, and neutral, the addressable market is massive. That does not mean Fetch captures it. It means the problem they are aiming at is real. This is not a consumer growth story. It is a long cycle infrastructure story, one where value compounds slowly and only shows up after systems become dependent on. So the 20 trillion model is not a promise. It is a ceiling, a statement about how big coordination and data really are. If automation without trust actually works, and that brings us to the final question. Does this system have a realistic path from where it is today to capturing even a meaningful slice of that market? Because if it does, this is early infrastructure. If it does not, it stays theoretical. Let's close it out. All right, now we get to everyone's favorite part. Show me the money. This is where we stop talking about ideas and start talking about numbers. And this is Lulu's lane. Lulu runs the math. No hype, no moon talk. Just scenarios and probabilities. Right now, the total crypto market sits around $3.09 trillion. That matters because price does not move in isolation. Everything scales off the size of the market. When people hear 20 trillion, they either laugh or get euphoric. But history says that kind of thinking usually misses the transition phase. People said the same thing about the internet in the late 90s. Too early, too speculative, too big to be real. Until real economic activity moved online, crypto does not need to replace everything. It only needs to replace enough. Enough settlement, enough coordination, enough infrastructure. So Lulu does not ask, will crypto hit 20 trillion? She asks, what happens if it does? Because if it never does, none of this matters. Now Lulu runs 3 scenarios. The first one is boring, but important. Crypto grows to 20 trillion. Fetch executes, but it does not dominate. It keeps roughly the same slice of the market it has today. That puts Fetch in the low single-digit billions in market cap. At current supply, that lands around $1 to $3. That is not a moon. That is relevance. Infrastructure keeping pace with the market. The second scenario is traction. Not hype, not narratives. Actual usage. Agents are deployed. Real coordination happens. Enterprises depend on it in 1 or 2 meaningful lanes. In that case, Fetch captures a slightly larger slice of the market. Now you are talking $10 to $20 billion in market cap, which translates to roughly $5 to $8 per token. That is infrastructure becoming useful. The third scenario is the moonshot. This is the world where an agent economy actually forms, where coordination without trust becomes mandatory, where builders stop asking whether to use Fetch agents and start assuming they are there. Not everywhere, but enough places that it becomes hard to replace. In that world, Fetch only needs half of 1% of a 20 trillion market. That was a $100 billion market cap, which puts price in the $30 to $40 range. That is the upside. Now, Lulu immediately adds the reality check. None of those numbers matter if execution fails. So we have to talk about black swans. The first is a technical failure, a serious exploit, a coordination bug, or a security issue that breaks trust. Infrastructure does not get second chances. The second is execution failure. If the tech is too hard to use, if builders struggle, if deploying agents feels heavier than existing tools, people walk. The third is being outbuilt. Another team ships a simpler, faster solution, or Web 2 absorbs the use cases before decentralization matters. The market does not wait. The fourth is scope creep, trying to do too much at once and not landing anything fully. Lulu's conclusion is calm. The upside exists, but it's conditional. This is not a guaranteed moon. It is an execution bet. If agents do real work, if coordination becomes necessary, and if value flows through the network, the upside math holds. If that does not happen, no chart saves it. That is Lulu's call. Now all that is left is the verdict. Does this earn a parking spot in the garage? All right, quick reset before we wrap this. None of this is financial advice. And just so we are clear, Lulu runs the numbers. And Lulu is a pig, a real pig. 4 hooves, snout, tail. So if you're taking financial advice from a pig on the internet, that part is on you. Now the dyno result, Fetch does not blow the doors off the room, but it does not stall. This is not a hype build. It's an endurance setup. Strong team, real tech, early usage, big upside, real risk. Final score comes in at 6.7 out of 10. That earns a watch list parking spot in the garage. Not conviction yet, not a write-off. Keep watching adoption. We keep checking execution. And if you got a project you want on the lift, let us know. Drop it in the comments. Yours might be next. Engine's hot, safety off, let it rip.